Hello everyone, we're back today talking about Chapter 1, Lesson 3, solving equations by multiplying or dividing. So remember, solving is always finding the answer, equation, something that has an equal sign, and we're going to be using multiplying and dividing today. So the objective is to solve one-step equations in one variable by using multiplication or division. So example 1, solving equations by using multiplication. So we're going to go ahead and solve each equation and then check our answer and make sure that we write that original equation whenever we're checking our answer. So right here, A, we have -4 equals k over -5, or k divided by -5, however you want to say that. We're going to isolate k and get k by itself. In order to do that, we're looking at the two sides of the equation. The one that k is on is k by itself. No, it's currently being divided by -5. So we need to do the inverse operation of division, which would be multiplication. So I'm just going to use parentheses to denote that I'm multiplying this side by this side. I'm going to multiply both sides by -5. What happens here is a negative and a negative become a positive, and then we're basically multiplying fractions, and those 5 cancels out, becomes 1, and we have gotten k by itself. Now over here, we just need to go -5 times a -4. A negative times a negative is a positive. 5 times 4 is 20. And then the k is over here on the right side. I always like to write the k on the left side, and it's okay to switch that because that's called the symmetric property of equality. Now we're going to go ahead and check our answers. So we're going to write that original equation, -4 equals k over -5. Okay, so how it originally was. And then we would be able to stick in this 20 for k. So we're going to substitute that value in. Instead of writing k, we're writing 20. And we have 20 divided by 5. Which is 4, and it's a positive divided by negative, which is going to be a -4, and that's a true statement, which means our solution, k equals 20, is the solution to the original equation. Perfect. Okay, let's go on to B. So we have p divided by 5 equals 10, and again, what we're trying to do is isolate that p and get p by itself. Okay, right now it's being divided by 5 on this side of the equation. And so we have to do the inverse operation of division, which would be multiplication. So we're going to multiply both sides by 5. Now you might ask, why did I just write times 5 over here, but over here I wrote parentheses? Well, whenever there's a negative and I multiply by a negative, I always like to put that in parentheses. Okay, so that's the reason. No negative here, I'm just going to write times 5 times 5. So those 5's cancel out and become 1, and then that's just 1 times p, which is p. So now p is by itself, woohoo! And then we go 10 times 5, which is 50. So there's our answer right there. And so we're going to check our answer by writing the original equation, just how it is. Then we're going to substitute that 50 in for p. So the next step would be this. And then I'm just going to read this. 50 divided by 5. 50 divided by 5 is 10. Or you can say, oh, what goes into both of these? Well, 5 goes into both of these. 5 goes into 50 10 times. 5 goes into 5 1 time. So you end up with 10 over 1, which is just the same thing as 10. So it's a true statement, which means our answer, p equals 50, is the correct answer for this equation. Perfect, perfect. Okay, let's go on to C. Okay, again, we're trying to solve for y. Get y by itself. So, right now, is it on by itself? No, it is not. So we're going to have to divide. It's y divided by 3. The inverse operation of division would be multiplication. So we're going to multiply both sides by 3. Look, just 3. Okay. And these 3 over 1, those 3's cancel out. We're left with y. We have a positive times a negative, which is going to be a negative, and 3 times 13. If I go over here and do that on the side real quick. 3 times 3 is 9. 3 times 1 is 3. So it's -39. And I'm going to go ahead and rewrite that using the symmetric property of equality, which just says I can just switch those, and it means the same thing. Perfect. So there's my answer. So I'm going to go ahead and check it. Write that original equation. So negative 13 equals y over 3. All right, now I'm going to substitute that negative 39 in. So negative 13 equals negative 39 divided by 3. Okay, so nothing to simplify there. I'm just going to rewrite that. But I do need to simplify this. So 39 divided by 3. I'm going to go up here. Go 39 divided by 3. 3 goes into 3 one time. 1 times 3 is 3. 3 take away 3 is 0. I drop down that 9. 3 goes into 9 how many times? 3 times. 3 times 3 is 9. And then no remainder, so we're good. So 13. So we know that 13 divided by 3 is 13, and then we know a negative divided by a positive is a negative. So we get the same answer, it's true. All right, we know that y equals negative 39 is a solution to this equation. All right, on to the fourth one, D. Okay, again, we're trying to solve and figure out what C is. So we need to get C by itself. Is C by itself? Let's go. Let's divide the equation into two sides. Is C over here by itself? It is not. It's being divided by 8. So we have to do the inverse operation of division, which would be multiplying by 8 to both sides. That's 8 over 1. Those 8s are going to cancel and become 1. 1 times C is just C. So now we have C by itself, which is exactly what we wanted. And then we just go 7 times 8, which is 56. So that is our solution, but we need to check it. So I'm going to write the word check. I'm going to write this original equation, which is exactly what you need to do. And then we're going to substitute 56 in for C. So we're looking at this and we're saying, okay, what number goes into both 56? So we can think about it, 56 divided by 8, or what number goes into both 56 and 8? Well, I know 8 goes into both. 8 goes into 56 7 times, and 8 goes into 8 one time. 7 over 1 is just the same thing as 7. So we have a true statement, which means our answer, C equals 56, is the solution to our original equation. All right, great job, and I'll see you back with example 2.